All right, everybody. Hello and welcome back to day 63 of Algebra 1. Today we're going to be undertaking a gigantic review in order to make sure that we understand everything that we've learned thus far. So let's go ahead and jump into it. So, first thing we want to talk about is graphing those crazy inequalities. So, we have a couple of different symbols that we can use with this: greater than, less than, greater than or equal to, less than or equal to. So, if I see a greater than or a less than, I know that this is going to be one of my dash lines, this guy. However, if we have that extra line that tells me equal, that means that it's definitely going to be a solid line. Now, let's talk about shading. For each one of these, they'll have a y on this side. And all I have to do is ask myself, are they asking for the bigger y's or the smaller ones? If my symbol is opening towards my y, they're asking for the bigger ones. They want my y's to be shaded in that are bigger than the equation. So here I would shade up, here I would shade down, up, down. Just as an example, this is how it would look. That would be approximately what those graphs would look like. All right, so let's go ahead and take a look at an example. Here they're going to ask me to graph these inequalities, and they gave me these two equations down here, and they're asking me which one of these are solutions. So this is like a really complex problem, but that's okay. We already understand this. So just to kind of take it back a little bit, we only know how to graph things that are y equals mx plus b. If it's not that, I don't know how to graph it. So I'm going to go ahead and I'm going to take this first equation, this guy, and I'm going to go ahead and paste it up there. And I'll do the same thing with this guy as well, just to give me a little bit of extra room to work. So let's take a look at that first one. This is currently in standard form. Ax plus by equals c. More or less. First thing I'm going to do is I'm going to identify what I need to be alone. Well, I'm looking to have something that looks like y equals mx plus b. So I need to get this y by itself. I need to get rid of everything that is bothering my y on the same side. I always get rid of whatever is not touching the object that I'm trying to keep around first. So since this 8x is not touching it, exciting move. Right? So here's my exciting move. Now I ask myself, did I multiply or divide by a negative number on both sides of the equation? Did I do that? No, I didn't. So my symbol is going to remain the same. Now I'm going to do my great divide. Whatever numbers is touching my variable that I'm focusing in on, I'm going to divide everything I see by that. Great divide. Now I ask myself, did I multiply or divide by a negative number on both sides? No, I did not. So my symbol stays the same. All right, so let's go ahead and graph that. That's going to be y equals 2x plus 3. So first thing I'm going to do is I'm going to look for my y-axis. Okay, and I'm going to say where's positive 3. There it goes. Let's make my little pen here just a little larger. All right, so now I'm going to take my slope, which is negative 2 over 1. So I'm going to go 2 down, 1 to the right. All right, so let's go ahead and count those. 2 down, 1 to the right. And I'm going to repeat that pattern until I run out of a graph. All right, so now I've gotten all my points placed. In the opposite direction, I do the opposite. 2 up, 1 to the left. 2 up, 1 the left, 2 up, 1 to the left. All right. So now I can go ahead and I can connect all my dots. And there's my fancy line. All right, we got our first one. So let us go ahead and work on our second one. So over here, this is not standard form. I don't know what they were doing, but that's okay. We can still deal with this. I still want something that looks like y equals mx plus b. So I'm just looking and focusing at my y, and I notice there's only one thing over there bothering it, that plus 2. So I'm going to move that 2 over. And because I did not multiply or divide by a negative number on both sides, my symbol's going to stay the same. Completely done. So let's go ahead and look at this. I see that my b value is negative 2. So I'm going to go ahead and plot that point first. Now I'm going to go ahead and utilize my slope. Positive 1 over 2, up 1, 2 right, up 1, 2 right. And I'm going to keep doing that until I run out of graph. All right. In the opposite direction, starting back in my y-intercept, I'm going to go 1 down, 2 to the left. I'm going to keep doing that until I run out of graph. Now I have all of my points laid out. I can go ahead and connect them with the line. All right, so I got my second line drawn. Now, my red line here says y less than or equal to. All right, so I'm shading out in this direction. Less than or equal to. Now, I did these guys in 2 separate colors just so it would be easy for us to do this. And actually, I made a mistake here and just noticed. Mr. Carmona didn't take the time to think about this, but I accidentally drew my line as solid. It is not solid. It is actually a dashed line because it doesn't have that extra line. So I'll go ahead and correct that now. There we go. All right. So now I got that. And I need to go ahead and figure out my shading. So this one is y less than. So I'm going to shade down here at the bottom. Now, I want you to notice something. The reason why I did this color change was because here in the red section where it's shaded red only, highlight red only, that's not a solution of both of them. That's only for the red. Over here in this blue part, that's only a solution to the blue graph. But in the purple part is both of them. Okay? So, as we remember, solutions can lie anywhere on a solid line or its shaded area. Solid line or shaded area. So, of course, that means that solutions exist all throughout here. And I'll just keep marking them off. And they also exist here. However, they do not exist up here on this on this dash line, nor do they exist out here, here, or here. Because that is not a solution for both of them. So in order for something to be considered a solution, it's got to be either on the solid red line that's also in the blue shaded area or in the purple shaded area. So let's look at the points that they want us to take a look at. All right, so 0, 0. That's not a solution. 0, negative 3. Yeah, that's 1. 5, negative 1. No, that's not 1. Negative 2. Negative 3. It's exactly on that dash line. That's definitely not a solution. So the only one that is a solution is that 0, negative 3. And that's it. All right. So here they were asking us a couple of questions about these graphs. Let's go ahead and just fill these in just to be complete. All right. So what was the slope of my first graph? Negative 2. My y-intercept was located at 3. My equation was y is less than or equal to negative 2x plus 3. This was a solid line, and we're shading blue. For my second equation, the one in blue, my slope was positive 1/2. My y-intercept was -2. My equation was y is less than 1/2 x minus 2. This was going to be my dashed line. And of course, we shaded blue. All right, let's continue forth. So I want you guys to answer this question for me. Let's go ahead and take a look at my exponential rules. So they all have super fancy names, but what's most important is that we remember the pattern, not necessarily the names. So whenever I see two of the same bases, these guys, with exponents multiplying together, all I have to do is just add them. So for this example, I say x to the power of 8 plus 4. X to the power of 12 would be my final simplification. Same thing with these dividing. If I see them dividing, I do what I would consider to be related to it, subtraction. So over here it would be x to the power of 8 minus 4, which is x to the power of 4. Whenever I see an exponent on the outside of a parentheses with other things on the inside, this is like distribution, right? So I just multiply. So this would give me x to the power of 32. Now if I see a negative exponent, that just means that all I have to do, flip it, drop the sign. As a side note, if I see a negative at the bottom, I can just flip it and drop the sign, and it can move to the top. So over here, this would give me 1 over x to the power of 4. There's also the zero exponent property, which means anything to the power of 0 other than 0 is always equal to 1. As a final note, I do want to mention that if I have, I'll do it the other way, a to the power of m divided by n, that its resulting, I guess, other form looks like this with the radical sign, okay? So let's go ahead and take a look at a couple of example problems. All right. So first thing I want to do is I want to break these down based upon what kind they are. Okay. So for this particular problem, I see 8 over 14, so I can reduce that to 4 over 7. I see x to the power of -4, x to the power of 2. Now I could go ahead and subtract these, or I could move my negative. So I'll move my negative for this one, make it positive. And for the second one, I'll go ahead and subtract, right? Because we could do either one. Noticing that because I already have a negative in the exponent, I have to do a double negative, making it a positive. Let's keep simplifying. And I'm done. All right, let's try another one. So here we're doing that fancy distribution. So 5 to the power of -2, x to the power of -12. It's a lot going on. Let's go ahead and simplify them by getting rid of those negative exponents. And I'm done. All right, here's one of those crazy problems involving area. They're asking me to figure out the area. They told me a radius, they told me a formula. Let's plug it in. So this one, because it's on the outside, we're going to do that kind of weird distribution. For each one of the ones that already has an exponent, they're simply getting multiplied. And I can start simplifying. All right. So, looks like there's my answer. And depending on how the person writing the test would do it. That pi could be in the front and the back or the middle. All right. So let's keep going. So here we have writing and solving systems of equations. So anytime we're trying to do this by hand, we definitely want to make sure that we are going to be writing these guys in standard form. Always. The reason is they're just easier to read like that. So the coefficients of either x or y must cancel for elimination. So we can multiply coefficients until they create a zero pair. Now, we can also solve these utilizing our calculator. Okay. So first, let's go ahead and focus on solving this one by hand. So I see here that I have 3x, 2x, 7y, 5y. The easiest way to do this would be just to take each of the numbers and multiply the opposite equation. So taking my 2, multiply everything in the top equation by 2, and then taking my 3 and multiplying everything in the bottom equation by my 3. I don't want to do that with the 7 and 5 because that's going to create really, really, really big numbers. We don't want to do all of that, okay? So one of those has to be negative. Doesn't matter which one. I'll just go ahead and pick the bottom one to be the negative. So I'll multiply everything up here by 2. And down here I'll multiply by negative 3. Now I can go ahead and just add my equations together. These will cancel. And I end up with something super simple to solve. I end up with y equals 4. I can go ahead and take that and I can plug it into any one of these equations. This guy, this guy, this guy, or this guy. However, I want to make this simple, right? So I want to pick the equation that's going to be the easiest. So I'll go back to 2x plus 5y equals 14. 2x plus 5y equals 14. And I'll continue to solve this. And I end up with an x value of negative 3. Now, I could go ahead and do this as well in my calculator utilizing LinSolve. So now that I'm here at my calculator, what I can go ahead and do is I can click on calculate to open up a new calculator page. Whoop, and it gave me the menu right away. And of course I'll see a blank page, so I can go ahead and hit menu, algebra, menu, algebra, solve system of linear equations. It's going to ask me how many equations I have, what are the variables. We're typically just going to stick with this. You can go ahead and hit OK. Let's go ahead and type these in. And I ended up with exactly the same answer. Negative 3, positive 4. Now, I could have also went over there and I could have graphed this, right? So I'll call this example A1. I could go ahead and rearrange these into my form, y equals mx plus b, and then I could go ahead and find out where they intersect. That's a little bit more work than doing the calculate page, because really all we're looking for is just this. So I would definitely say this is a really powerful tool. So let's go ahead and look at another problem. Let's look at one involving substitution. So one of the equations must be solved for either x or y, meaning that the variable is isolated or by itself. So I'm looking at example number 2. It looks like my y is by itself. So that means that I can take that equation and plug it in where I see a y in my second equation, giving me an equation that only has x's in it, so that way I can solve it. So let's go ahead and do that. 8x all right, so now I'm going to go ahead and combine like terms. I'm going to go ahead and do exciting move. Great divide. And I ended up with an x value. Now I need to go ahead and plug this back in and find y. So when choosing in between these two equations, I'm going to opt to choose for the one that already has y solved, because I could just plug it in and get a y value without having to rearrange or do any extra math. I'm just simplifying, okay? So y equals negative 3 times negative 2 plus 16. So the answer they were looking for was y equals 22. Now, whenever it comes to these kind of problems, remember we usually are going to have one that looks like x plus y equals the total number of items, and then price times x plus price times y equals total cost, okay? So I'll write that out. So I'll just call them items A and B. That's usually the form that they're going to follow, this standard form, okay? So let's go ahead and read the question. The soccer team is having a bake sale to raise money. Pies cost $4 each. Brownies cost $2 each. Marie spends $26 for 8 items. How many pies did she purchase? All right, so we got 8 items. So pies plus brownies equals 8. $4 for a pie plus $2 for a brownie is a total of 26. And it follows that setup exactly. So I could go ahead and use my substitution elimination, but I'm going to go ahead and use my calculator. I'm going to go ahead and do another LinSolve, menu, algebra, solve system of linear equations. And just to be a little bit difficult, I'm going to go ahead and change these to P and B. P and B. All right, so let's go ahead and type these in. P plus B equals 8. And 4P plus 2B equals 26. 5, 3. She bought 5 pies, 3 brownies. Go ahead and write that down. All right, so I got that. 5 pies, 3 brownies. She wanted number of pies. So my answer would be our studying of items that we have done thus far this year. So now we're going to talk about factoring trinomials, things with 3 terms. Okay, so in order to do this, we have to find 2 factors that when they multiply, they are equal to A times C, and when they add, they're equal to B. Okay, so these equations are always going to come in the form, remembering that B or C could be equal to 0. Okay, so let's go ahead and factor the very first one. So first step is I'm going to ask myself, is there a greatest common factor? Something that I can divide each one of these by evenly? There is not. So then I ask myself, all right, what is A times C, which is 1, times 12, which is 12. So I need those 2 numbers that will multiply together will give me 12, but will add together to give me 8. If I don't know what these numbers are, I could start at 1, 2, and there are the numbers. 2, and 6. Now, the other way to do this is for me to swing over to my calculator. I'm going to go ahead and go home, open up a new graph page. And for this particular one, I'll go ahead and call it that. And I'm going to type in A times C divided by X. It's going to give me a really crazy graph, but that's okay. I'm just going to look at the table. These are pairings of possible numbers, okay? So 1, 12, 2, 6, 3, 4, 4, 3, and then 5 and 2.4, which of course is not something that we want because we want whole numbers. So we have our numbers. Let us go ahead and split apart our B term. So x squared plus 2x plus 6x plus 12. So I look at my very first two terms and I say, do they have something in common? Usually this is going to be an x into x plus 2. Over here, I ask myself, is there anything in common? I see a positive 6. I make sure that the inside of these guys matches exactly, and it does. So that means I can combine like terms. And now I am completely factored. Now, I could verify this a number of different ways. However, I want to go ahead and just verify it by graphing them to ensure that I did this correctly. So remembering, I like to name my things just so I can keep track of them better. So let me go ahead and finish typing in this equation. All right, so that's what it should look like. And it should have zeros located at negative 6. Remember, opposite of this divided by that. Negative 6, negative 2. And that's 1, 2, 3, 4, 5, 6. Yes, that is negative 6, negative 2. I can trace this, graph trace. I'm going to go ahead and just keep on heading down. And look, there's my 0 located at negative 2 as I predicted. And my other 0 located at negative 6. Now I can also verify this by graphing a function. And I'll go ahead and type in my factors exactly as I have them. And look at that, it lies exactly on top of my graph, meaning that this has absolutely got to be my answer. So I got that one correct, okay? All right, so let us go ahead and take a look at the very next one. So notice how they only changed the minus. So for this particular one, I'm going to go ahead and multiply a times c, 1 times 12. And I need numbers that add up to negative 8, meaning I have two negative numbers. So I'll cheat a little bit and steal my number from last time and see what happens. And those do add up to negative 8, and they multiply together to give me 12. So I'm going to go ahead and split apart my second term. And I go ahead and look at the first two terms in order to see if they have anything in common. They do have an x. And I look at the second terms, and I can actually pull out a negative and a 6. The reason why I want to pull out that negative is because it's attached to the coefficient that is on our x with the largest exponent amongst these two terms, okay? So I'm going to pull out a negative 6x, a negative 6, and I'm going to divide every single item by that. I should see exactly the same thing on the inside. And I do. And I do see exactly the same thing on the inside. So I can go ahead and combine my like terms, and I'm now factored. I'm just going to verify this in my calculator. All right, so I'm going to go ahead and type that in just to make sure that that is the same. Okay, so there's my original one. Let me go ahead and add a graph that is going to be answer 4. All right, so I'm going to go ahead and add in the factors that we found, and let's make sure that these graphs are exactly the same, and they are right on top of each other. that means that this is definitely my answer. All right, let's look at another one. So first thing I do, A times C, add up to B. So I'll say, all right, I know I'm going to have at least one negative number because they multiplied to give me a negative. So it's one negative, one positive. And the positive number has to be bigger because this is positive whenever they're added together. So I'll say, all right, -1, +12, no. -2, +6, yes, those are the numbers. So I'll split apart my B term. I'll go ahead and factor the first two terms, factor the second two terms. I notice that the insides line up perfectly with each other, so I can combine like terms, and I ended up with the exact right answer. I can verify this by graphing it, but I've already showed you guys how to do that. You're just going to match it. All right, let's do the same thing here. So, no greatest common factor, -12, add up to -4. So that's interesting because if you notice, 4, -4. So it's going to be the opposite, right? These are opposites. So I'll just flip those numbers around. And look at that. There are my answers. So interesting how that pattern exists. That's something that I want you guys to be cognizant of. Let's go ahead and split apart my B value. Let's factor out of the first set, factor out of the second set, verify that the inside of these are exactly the same, and they are. Combine like terms. And of course, we can graph this to ensure that this is the correct answer. Same exact thing if we have an A value that's not 1. So first thing I'm going to do is I'm going to say, all right, do these guys have anything in common? Well, 5, 18, 9. No, I don't see anything in common because 5 is a prime number. So first thing I'll do is I'll multiply A times C. Gives me 45. So I need two numbers that will multiply together will give me 45. And will add together to give me -18. Okay, so obviously there's got to be a negative number there. And obviously, because this is positive, if there is one negative number and this is positive, then this has absolutely got to be two negative numbers. So let's try a few. -1, -45, no. -3, -15, yes. Those are my numbers. Let's go ahead and split apart that B term. All right. So now I'm going to go ahead and factor out of my first two terms. I see they have a 5x in common. Over here, I'm going to factor out that -3. Mind you, whenever I divide +9 by -3, I end up with -3. Okay? So I see that the insides match perfectly. So that means I can go ahead and combine like terms. And guess what? Now I'm completely factored. I can go ahead and plug this into my calculator as well as my original equation to make sure the graphs are exactly alike to for sure say this is my correct answer. Let's look at the next example. Here again, I ask myself if I have a greatest common factor. I don't. 7's a prime number, and these are not multiples of 7, so I'm good. I'm going to go ahead and multiply A times C. I get -60. So I need two numbers that will multiply together will give me -60. And when added together will give me -7. So I asked myself, all right, when they're added together, they're negative. And when they're multiplied together, they're negative. So if I multiply and get a negative, one's got to be negative, one's got to be positive. And this tells me the negative number is bigger. So I'll go ahead and say, -60, +1. That's not it. +2, -30. Nope. +3, -20. No, but we're getting close. +4, -15. No. +5, -12. Yes, those are the two numbers I'm looking for. So let's go ahead and split apart that B term. And now I'm going to go ahead and factor out from the first two terms. I see that they have a 5x in common. And over here, I'm going to go ahead and do the same thing. I see that they have a negative 6 in common. And noticing that this changed to positive because I divided by negative 6, I notice that the inside of my parentheses is exactly the same, so I can go ahead and combine like terms. And of course, the thing on the inside is what I'm referring to whenever I say that. And I'm completely factored. I can plug this into my calculator, graph it, make sure that they're exactly the same. All right. So, next part, multiplying binomials. So we originally started off with this topic showing that we could multiply these guys. And we use these little fancy boxes to help us keep everything straight, remembering that it's usually the diagonals that we end up having to combine like terms. So this is just working backwards from factoring. We're taking our factors and taking them back to the original equation. So I'm going to go ahead and I'm going to break this apart. 2x plus 7 multiplied times 3x minus 5. So 3 times 2, 6x squared. 3 times 7, 21x. Negative 5 times 2. And negative 5 times 7. And now I go ahead and combine any like terms. And I end up with 6x squared plus 11x minus 35. There's my original equation. I can graph this first part and the second part to ensure they're exactly the same and verify that I got the correct answer. All right. A rectangle has a length of this and a width of that. What is the area? So they're asking me to multiply these two. I'm going to go ahead and use this box just to help me keep all of that straight. So 4 times 2, x times x. 4 times negative 3, carry my x. Negative 7 times 2, negative 14x. Negative 7 times negative 3, positive 21. Let's combine like terms. And I end up with the result. That is the area of my rectangle. Let's continue with finding the area of this triangle. So, the formula for the area of my triangle is going to be base times height, all divided by 2. So I see a base, I see a height. Let's go ahead and plug those in. 4x minus 5 multiplied by 2x plus 6, all divided by 2. Okay, so I want to go ahead and use my box method to multiply out that top part just simply because I want to keep it easy. So 4x minus 5, 2x plus 6, 2 times 4 is 8, x times x, x squared, 2 times negative 5, negative 10, bring my x down, 6 times 4, 24x, 6 times negative 5, negative 30. And I end up with 8x squared plus 14x minus 30, all divided by 2, right? Because we've got to carry that down. However, whenever I look at this, I notice these guys are all even. So I'm going to go ahead and work out that division. And I get my final answer. This is what the area of that triangle would be. All right, let's keep going. So, geometric sequences. So in geometric sequences, we multiply. Okay? The explicit rule for the nth term, the one that we're looking for of a geometric sequence, is a sub n equals a1 times r to the power of n minus 1, where a1 is my first term and r is what we call our common ratio, what we multiply by. Remembering that it can be a fraction if we are dividing, or it looks like we're dividing. It's a fraction that we're multiplying by, okay? So, very first thing I do is I identify my first term, negative 10. So I have a1. Now I want to go ahead and find my r value, not my D, R value. That's a mistake. So I'm going to say, all right, how did I get from negative 10 to positive 50 multiplied by 5, negative 5? And it looks like that pattern holds up. So my R value is negative 5. Now I can go ahead and compose my equation. And there it is. If I needed to find a specific term in the formula, so for example, the 20th term, the 50th term, etc., etc., etc. So to find the nth term of a sequence, change the value of n in the explicit formula. So for example, if they're asking me to find the 7th term, that means n equals 7. Okay? So I'm going to work this out by hand, and then I'm going to go ahead and utilize my calculator to verify my answer. So here's my equation. And I'm going to change all the n's that I see into a positive 7. And of course, I can drop that into the calculator. Now, I do want to go ahead and actually plug this into a calculator. And we usually use an X instead of an N in our calculator. And we'll go ahead and move over to our calculators. So I'm going to go ahead and add myself a calculator page. I'm going to refer to this as A for, I'll say example 5 of X. Hold on. Excuse me. Wrote that in wrong. All right. So first thing I'm going to do is I'm going to type in that equation. -10 multiplied by -5 to the power of x minus 1. And I'm going to store that, control store, as a example, and I'll call that 5 of x. Okay, so now I've stored my equation. Now I'm going to go ahead and ask it whenever n is equal to 7. A example, 5 of 7. And it's going to spit back an answer. There it is, negative 156,250. All right, so let us head back over here. So there's my answer. I wrote it down. A sub 7 is equal to that. All right, let's go ahead and take a look at our next one. So in arithmetic sequences, we are adding and or subtracting. The explicit rule for the nth term of the arithmetic sequence is the following. Where a sub 1 is the first term and d is what we call our common difference. As a side note, these guys are linear, meaning if I run a linear regression, it will give me the equation. It just will not be in this form. It will be in y equals mx plus b form, which is usually how they ask you to give it anyways. So I'm going to go ahead and look, and it looks like from here to here, we added 5, and that pattern holds true. So d is equal to positive 5. The first term that I see is negative 10. So I say a sub n equals negative 10 plus n minus 1 times 5. And if I wanted to go ahead and simplify this, I could go ahead and do that. So negative 10 plus 5n minus 5, 5n minus 15. And this would be what the calculator would give me. Now, if I was to go ahead and utilize this in order for me to find my equation utilizing my calculator, I would have to make note of the fact that these guys are my y values, these are my range, always, 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 because my x's are going to be the counting numbers, 1, 2, 3, 4, 5, signifying which term they are. So of course I can do the same exact step as last time to find that seventh term. I'm going to go ahead and plug it in. So a sub 7 is going to be equal to 5 times 7 minus 15, which is 20. Let us go ahead and verify that utilizing my calculator. So I'm going to say 5x minus 15, and I'm going to store that as example 6 of x. And then I'm going to ask it, hey, what is the seventh term? And it's going to tell me 20. Exactly the same thing that I got earlier. Okay. So let us go ahead and continue. So, of course, you guys are going to be doing all the example questions. And that is it. Your assignment for the rest of the day is to go ahead and finish these up. See you guys next time.